Here's an example of converting a circle's equation from general form into standard form, but it has coefficients on x squared and y squared, which can make the process of completing the square a little bit trickier. So I'd like to help you out and walk you through this one. So in this particular situation, what we first need to do, as always, is get the terms that have x's together and the terms that have y's together. So I'll just rearrange my items and go ahead and move that 24 to the other side, and it's going to become a negative 24 because you're subtracting it over. Now, to handle the coefficients, you could at this point divide everything through by 4, or you could factor out 4 from both sides. I'm sorry, you could factor out 4 from the x squared term and the 25x term, and then 4 from the others. I think it's going to be best to just simply divide both sides of the equation, which you're perfectly fine to do as long as you do it to each side completely, by 4, so that we end up with x squared minus 25 fourths x, and I'm going to leave a little bit of space for the completing the square step, then plus y squared plus 13 fourths of y equals, oh, you know what? I want to leave a little space there as well, equals negative 6. Okay, now completing the square. To complete the square, we take the term that is multiplying x and we divide it by 2. So I'll come off to the side here. So if I take negative 25 fourths and divide that by 2, the way that we need to think about that is when we're dividing fractions, we think of inverting and multiplying fractions instead. So let me go ahead and just make this 2 over 1, so that 25 fourths times 1/2 is what we're actually doing here instead, which will become negative 25 eighths. Now, I have divided that value by 2. To complete the square, we then need to square that term, because you take whatever number is multiplying x, divide it by 2, and square it to get your complete the square term. Okay, so this term, 25 squared, just to make sure I don't mess that up accidentally, 25 squared, oh, there it is 625. All right, so plus 625 over, then 8 squared is 64. Okay, now completing the square on the next term. So the same sort of thing is going to happen. When I take 13 fourths divided by 2, it's going to end up being 13 eighths. So when I square that, it will be 169 over 64. And let me just double check that number as well. So 13 squared, yep, that's right. Now, I can't add these values to this side of the equation without doing the same to the other side. So 625 over 64 plus 169 over 64. Okay, now it's important not to just get intimidated and quit because you have fractions involved in the problem. It will take more time, but you can still persevere if you understand how to combine like terms with fractions, getting the common denominator that is, and so forth. So that's all we're doing at this point. Now, factoring. The secret to factoring with completing the square is that these terms right here, the x squared minus 25 fourths x plus 625 over 64, you might be thinking in your head, this is going to be so difficult to factor. But here's the thing. Whenever I do factoring with completing the square, this thing is a perfect square trinomial, which means it factors into something that is very predictable every single time. It's always x plus whatever half of this term is. So half of negative 25 fourths, we already said was negative 25 eighths. So there we have it. That's all we need to do in order to factor this. In the y's, I would have y, this time it's going to be a plus, but it would be plus 13 eighths squared. So if you're doing completing the square at this point by taking these trinomials and working through the process of factoring, you're doing too much effort. At this point, it's always going to just factor into x plus half of whatever this number is. Very simple. Now it looks like we have some work to do with this other side of the equation for fractions. So let's see what we need to do here. First off, negative 6 written as a fraction with 64 in the denominator. Let's see, 6 times 64 is 384. So it's going to be negative 384 over 64 plus 625 over 64 plus 169 over 64. Whoops, 169 over 69. Let me try that again. All right, now the numerators we can add together. So negative 384 plus 625 plus 169. That's 410. So this is going to end up being 410 over 64. All right, now it's in standard form at this point. The standard form is of the form x minus h quantity squared plus y minus k quantity squared equals r squared. So in this case, my value of h is 25 eighths, k is 13 eighths, and then r squared, if I take the square root of the numerator and denominator, it would be the square root of 410 over 8. And that would be the location of the center and the radius, if that was being asked. But it's not in this case. So our final answer here in standard form is this right here. So a little extra work with fractions, but if you just persevere through the fractions, it's really not that bad.